Welcome to Flipped Classroom. Our topic today is algebra and we are looking at the index laws. So this video is about the first two index laws. Our learning intention is we are learning about the first and second index laws, and our success criteria is I am successful when I can explain the first index law and explain the second index law. When we're looking at index numbers, we have questions like this. Can you simplify 2 to the power of 3 times 2 to the power of 5? With previous problems, we've looked at can you simplify this question. And the way we do that, and we did this in that video, which you can click on the top corner if you have forgotten about it, we can expand out the two index notations so that we've got 2 times 2 times 2 multiplied by 2 times 2 times 2 times 2 times 2. Then we get rid of the brackets and then we simplify it back down to an index form. But this can actually be done really quickly using the index laws. The first index law is called the index law of multiplication. And if two terms have the same bases and are multiplied together, we can add their indices together. So an example, which is the one we used before, 2 to the power of 3 multiplied by 2 to the power of 5. We can add those two indices, the 3 and the 5 together, and we get 2 to the power of 8. And how does this work? Well, we just did this with the previous one. We got 2 to the power of 3, and there's 3 lots of 2's there. We have 2 to the power of 5, and you can see there are 5 lots of 2's there. And when we multiply them together, we get 2 to the power of 3 multiplied by 2 to the power of 5, and you can see there's 8 lots of 2's there, so we get 2 to the power of 8, and we can just count those through. So this gives us a general formula of a to the power of m multiplied by a to the power of n is a to the power of m plus n. And this works for any value of a as long as it's not 0. Now our second index law is the law of division. So very similar to the previous one, if we have two terms with the same base and they are divided, we can subtract the second index from the first. So what does this look like? So here's an example. We have 2 to the power of 8 divided by 2 to the power of 5. And as you can see, I've subtracted the 5 from the 8. So we got 8 minus 5 up there as an index. And that gives us 2 to the power of 3. And again, how does this work? Well, we can start off with 2 to the power of 8, and you can see I've got 8 lots of 2's there, all multiplied by together. And 2 to the power of 5, again, 5 lots of 2's, all multiplied by together. And when we divide them, we get this fraction. And as you can see, I've gone through and I've marked out the pairs that could be cancelled from top and bottom. And all that's left is 3 lots of 2 up the top and none down the bottom. So that gives us 2 to the power of 3. So our general formula for this is a to the power of m divided by a to the power of n equals a to the power of m minus n. Again, that can be for any of the bases as long as that a does not equal 0. So here I have some worked examples. Simplify the following using the index law for multiplication. I have my two questions. I have question A and question B. Question A, I've got my thinking and my right drawing on the right hand side. So my thinking is what I'm thinking and my right drawing is what I'm showing my teacher so that they know that I know about this question. So first off, I look at all the bases and all the bases are the same, so we can add the indices. So you can see there I've rewritten the question, x to the power of 3 times x to the power of 7 times x to the power of 2, and then I've written equals x to the power of 3 plus 7 plus 2 because I've added up those indices. And then I simplify this by adding those indices together. 3 plus 7 plus 2 is 12. And I rewrite it as equals x to the power of 12. For part B, we do exactly the same thing. So I've rewritten the equation a to the power of 5 times a to the power of 3. And I've written next to that the added version of it. So I've got a to the power of 5 plus 1 plus 3. Because remember, if there is no power above the a, it's actually to the power of 1. So there's actually a 1 there that we don't write because we're being efficient. And we simplify that again, a to the power of 9. Now let's do some of these for division. So I've got u to the power of 8 divided by u to the power of 5. So let's look at that one. And I do exactly the same type of thinking. So my thinking is, are the bases the same? Yes. So we can subtract those indices. So I've rewritten the equation and then I've written equals u to the power of 8 minus 5 because that shows my working, and then I simplify it to u to the power of 3. For part B, we do the same type of thing. We rewrite the equation and then we do our subtraction. But this time I can only subtract each variable by itself. So if you have a look, a to the power of 10 over a to the power of 3, I've got a to the power of 10 minus 3. And b to the power of 6 over b to the power of 2, I've got b to the power of 6 minus 2. They're separated based on their variable. And then I simplify that again. 10 minus 3 is 7, so that gives me a to the power of 7. And 6 minus 2 is 4, so I get b to the power of 4. And that's as far as it can simplify. Because the bases are different, we can't merge them together. For reflection for this topic, I want you to think about the operations that we use for the first and second index laws and how they relate to each other. So the first law is the multiplication law. The second law is the division law. The first law, we add the indices together. The second law, we subtract the indices together, and try to see how all this is related. As always, like the video and subscribe for more flipped classroom videos.